All right, let's talk about derivatives. And let's use a very nice function to do that. So this function, as you can tell, is a parabola with the vertex at 1, negative 2, right? And notice that I go over 1, up 1. I go over 2, up 4. I go over 3, up 9. So the leading coefficient, is 1. Okay? So the equation of this would be, remember vertex form? Y equals A is 1, x minus 1 squared minus 2. You follow? You follow what I did there? I just made up this parabola because it's a nice one to look at to talk about what derivatives are. Whoops, I didn't mean to do it that much. Okay? So this is my parabola. Let's expand this out and look at what the form. This would mean that y equals x squared plus 2x, minus 2x plus 1 minus 2, which means x squared minus 2x minus 1. So this is my function f of x. Okay, here's the question. What does derivative mean? Here's the answer. The derivative means the slope of the tangent line at any given point of the graph. That's what derivative means. So I'm going to wave my hands over it. I'm not going to explain how I got this formula because you may or may not know how to take the derivative easily yet. But here's what the derivative is. F prime of x is how we write it, equals 2x minus 2. Okay? 2x minus 2 is a different line. Let's graph that line. Here's negative 2. 2x means I go up 2 over 1, so there's another point. So the slope, so the graph would be like this. Ish, right? That's the graph of f prime of x. You follow? Okay, what does that graph mean? Well, that graph tells you at every given point, it tells you the slope of the red graph, of the tangent line of the red graph. You ready to be amazed? Are you ready? So let's look at every single point, and I'm going to color code these. So let's first look at this point right here. That point corresponds to what point? That point. What's the value of that point, that purple line? 0. What does that mean the slope of that point is? The slope of the tangent line of that point, what is it?
0.
It's 0, which is exactly what it is. The tangent line is horizontal at that point. Got it? Let's take the next point. I will use puke yellow for this point right here. See that point? Let's go up to the line. What's the slope? What's the value of that, I should say? It's 2, right? So the slope of the line, of the tangent line, at that point is 2. Which it is. There's the tangent line. The slope of that line is 2. The tangent line is the line that just nicks it barely. Follow? Are you with me? Are you guys amazed yet? You should be. Let's do the next one. Burnt orange. That's right, burnt orange. See that point right there? On the red graph, that point. Let's go up or down. Now I've got to go down. Hey, what's the slope? What's that value right there? What's that y value of that point? Negative 2. What? Negative 2, that's right, negative 2, because it's kind of symmetric here, which means the slope at that point is negative 2, which it is. The slope of that tangent line is negative 2 at that point. Let's keep going, because this is so fun. Let's go pink now. Dark pink. That point right there, I'm at 2, right? Or 3, rather. I'm at the x value of 3. Let's go up or down to the graph. 3. What does that look like roughly? Did I do that right? All right, this isn't exact, but that should be 4 right there. That should be 4. So what's the slope of the tangent line at that point?
4.
It's 4. And hey, guess what? It is 4. That's the tangent line at that point. You see how the further you get to the right on that red graph? See how the further you get to the right, starting at the vertex, the more steep the tangent lines become?
Mm-hmm.
That's what derivative is all about. That's
I didn't get any of that, but that's okay. I just want to.
all right. So let's say the question asked, let's say that the question gave you this red equation and said, at what point is the tangent line to f of x horizontal? At what point is the tangent line to f of x horizontal? Look at my picture and tell me what the answer is to that. At what point is the tangent line to f of x, this f of x, horizontal? How many tangent lines have I drawn up here?
A lot.
I've drawn 4. Orange, yellow,
Is it orange?
pink, brown.
Orange is orange.
Which one is horizontal?
Orange.
It's orange. How would I have found that? How would I have found at what point it's horizontal? I would know what I would do is I would take this equation right here, the derivative equation, and I would set it equal to what?
0.
I would set it equal to 0. Why am I setting it equal to 0? Because what do horizontal lines have?
0. They're not.
The slope is
0.
0.
So you said.
And what does this give you again? What does the purple equation give you? It is the formula for the slope of every tangent line on this graph
At a given point.
at any given point.
Okay, so
At
you
any
set
point.
it equal. So once you find the derivative, you set it equal to 0, and then whatever that point is, that's the point where your tangent line's horizontal.
Yep. But you have to. You're going to only find the x value when you do that,
so
right?
I was gonna ask how to find the
So
y value.
2x minus 2 equals 0. That means x equals 1 is the x value. So y equals, plug it back into f of x, not into f prime of x,
Okay.
because you're no longer talking about that. Now you're talking about what point on f of x. And when you plug that in, you'll get -2. So your point is 1 comma -2.
Got it. Okay.
Okay?
Thank you.
So that's the major takeaway. That's the concept behind derivatives and tangent lines and all that good stuff. Super important that you understand.